This time we're going to describe the graphs of quantitative variables by focusing on their center, or the measure of central tendencies, which includes mean, median, and mode. Let's formally define what the measure of central tendency means. A measure of central tendency is a statistical metric that identifies the center or typical value of a data set, representing the center of the distribution. The most common measures are mean, arithmetic average, median, and mode. Time to go over the measure of central tendencies. We're going to have some quick definitions to mean, median, and mode. We're going to first start off with mean. So for mean, we're looking to sum up all the values in a data set and dividing by the total number of values. Now let's look at median. In order to figure out what the median is, we're going to arrange the data in order and choosing the middle value. And the last central tendency is the mode. It's just the most common value. And those are our measures of central tendencies. We're going to first focus on the mean in more detail. Let's get a formal definition for mean. Mean, sometimes called arithmetic average. The mean of a distribution of a quantitative variable is the average of all the individual data values. Now we're going to go over some notation. Typically, when we see the notation x with a bar on top, we think this is at the mean or average. However, this is the average of a sample. In other words, we're going to have the sum of all the data divided by the number of data. And here's a algebraic way to represent x as each of our individual data values, and n represents the number of values. We're going to introduce a symbol to represent repeated addition, and then that would be this funny looking E symbol that we're going to say is the sigma symbol to represent the sum of values. And the I, when we're looking at this new formula setup, the I here represents each individual values, meaning this represents 1 or x sub 1. And when it is 2, it will represent x sub 2. And then it goes on forever until we reach our n for x sub n. N represents the number of data, or it represents the number of observations, or this symbol here is going to be pronounced as x bar. And this other symbol here with the funny looking E is our capital Greek letter for sigma, is the shorthand for adding them all up, or the sum. Here we're talking about sample mean. The sample is just a smaller portion of the population. And we're going to talk about population mean next. Now let's talk about population mean. We typically use the symbol mu, or a weird looking M symbol with the extra little tail, as the notation for the population mean, which represents the average of all data points in an entire population. X bar is used when we're working with a sample, which is a subset of the population. So x bar is a lowercase x with a dash on top. Mu is the population mean. So let's think about the entire population of United States to represent mu. That means we're looking at something close to 340 million people. And if we were to find the average, some calculations involving all 340 some million people, then we'll use mu to represent that. If we were to sample individuals from each of the 50 states, let's say we took one person from every single capital. If we found some kind of average on these 50 people, then we will use a lowercase x and put a bar on top to represent that sample. Let's go over a sample mean question. Let's say we sample 47 students out of a school and ask for the last digit of their telephone number. What we end up doing here is looking for the mean or the average. Sometimes we're going to think of this as a weighted mean. There is 7 copies of 0 where the weight is the 7, There's 5 copies of 1 where the weight is the 5. There is also 5 copies of 2 where the weight is 5. And then we can continue this process. Whereas 3 copies of 3, 5 copies of 4, 4 copies of 5, 6 copies of 6, 3 copies of 7, 5 copies of 8, and 4 copies of 9. So we're going to end up adding all of these values together and divided by our total number of values, which will be 47. So our x bar, or our arithmetic mean, or our sample mean here, is going to be the sum of all the values divided by the number of values. This will give us an average of approximately 4.2. So this average is telling us that our approximate uniform distribution, which is this rectangle in shape, has a center that's approximately around 4.2. And this center represents our average, or arithmetic mean, or sample mean. So we can treat the arithmetic mean or sample mean of 4.2 as one of our versions of centers. The next central tendency we're going to be talking about is median. So let's look at a formal definition here. The median represents the middle value of a distribution, dividing it into 2 equal halves. When we're dividing the data into 2 halves, one half will be smaller than the median, and the other half would be larger than the median. Let's just have some formal guidelines to find the median. We always arrange the data in ascending order from smallest to largest. If the number n of the data values is odd, the median is the middle value in the order list. The n numbers of our data value is even, the median is the average of the 2 median values in the ordered list. Now let's look at an example where we go over median. Let's look at the data set we had earlier about the last digit telephone number. We had the following roughly uniform distribution. So what we can do is start counting from one end and the other and start crossing them out until we find the middle. So if we cross 1 0, we will cross out 1 9. We can cross out 1 2 3 4 5 6 more zeros. So then in order to do that properly, we'll count 1 more 9, 2 more 9, 3 more 9, then 1 8, then 2 8, then 3 8. So if we eliminate 6 values and 7 values on the right, which includes 4 9s and 3 8s. Then we continue this process with the ones. So we're going to eliminate 1, 2, 3, 4, 5 ones. So we're going to continue from where we left off on the 8. That'll count as 1, 2. And we need to eliminate 3 more. So we count 1, 2, 3. So the equivalent of eliminating 5 ones would be 2 8s and 3 7s. Then we're going to keep counting until we figure out what the middle number is. We can count 1, 2, 3, 4, 5 2s that are going to be eliminated. So we can count 1, 2, 3, 4, 5, 6 that are going to be eliminated. Now we have 1, 2, 3 3s eliminated, 1 6, and 2 5s. Now that we're getting closer to the values, we want to slowly eliminate one value at a time. So we'll eliminate 1 4, and that'll be the same thing as getting rid of 1 more 5. Then we'll eliminate 1 more 4, and that'll be the same thing as eliminating 1 more 5. So we can now see at the end here, the median is going to be a 4, because that's all that there is left. We can eliminate 1 more 4 on the count from the left, and it'll be the same thing as eliminating 1 more 4 from the count on the right. But we'll still be left with 1 4, and that is still the median. So that's one way to try to figure out what the median is. We'll count from the left, count from the right, keep eliminating values until you find the middle value. Another way to find the median is strictly take all of our values or our entire data set, divide it into 2 equal halves, so that we can have a lower half and a higher half. So if we took 47 divided by 2, we'll get something about 23.5. So if we count approximately 23 values, this will create our lower half. And if we count 23 values on the other side, that will create our higher half. So what we can do here is count 23 from the left, starting with 7 plus 5 more, which gives us 12, plus 5 more, which gives us 17, plus 3 more is 20. And we'll have our 23 and a half in the 4 section. If we count here, 21, 22, 23, and the half part would be our median. So there it is. There's our median. Time to talk about mode. Since mode is the most common value, let's have a formal definition for this. The most common number that appears in the data set. Let's check out a quick example. Again, let's look at our last digit from 47 students, phone number. In this list of values, we can see that the number shows up the most for our distribution is 0. So the mode is equal to 0. There are 7 zeros, and there are no other number that is equal to or greater than 7. To remind ourselves, it is possible to have more than one mode as long as the numbers are equal. And that's mode. Okay, now we're going to combine the shape of the graph and measures of central tendencies. In this situation, our first graph to the left is a left tail graph or skewed left graph. And our graph in the middle, if we are connecting each of its border points or corners, we can see that this is a symmetric graph. And in our last graph, if we're connecting the corners again, we can see we have a right skewed graph or a positively skewed graph. Describe the distribution based on the shape and center. So we have left skewed, symmetric, and right. Now we're going to measure the different types of center. The mean or arithmetic average. So for the symmetric graph, we expect the mean to be right in the middle. We can maybe call this X bar to represent our mean or average. For the left skewed graph, since we have a few values on the left that can be treated as possible outliers, what it does is pulls down the mean, and we expect the mean to be somewhere further to the left. So the mean can be somewhere on the left, closer to the value of 6. So we can say, hey, that's where our X bar is, or our mean. Similarly, when we talk about the right skewed graph, since it pulls the graph to positively to the right, we can expect a possible mean closer to the value of 8. So our X bar would be our mean somewhere maybe in the 8 range. Next, we talk about the median. When we're looking at the median, we're looking at the value that divides our data into two equal sets, a lower half and a top half. For the symmetric graph, the median also where the mean is at. So we'll have the median on the mean. In this situation, we expect the mean to be 7. Whereas on the left skewed graph, the median can be somewhere in between 6 or 7. So that's where our median might be. We have to remind ourselves extreme values like the values to the left that pulls down our graph or creates the tail of our graph does not affect median. So similarly, on the right skewed graph, we should expect the median to be somewhere between 7 and 8. Again, the right skewedness of this graph doesn't affect the median. And the last one we want to look at for measuring central tendency is the mode. So the mode is just the number that shows up the most. In the symmetric graph will also be 7 because that's the number that shows up the most. When we're looking at the other graphs to determine the mode, we can see that the mode is 7 as well, and it is to the right of both the mean and the median. So there's our mode, which is 7 there. And in our right skew graph, we'll also have the mode at 7. However, it's to the left of the median and mean. And that's it for now. That's the describing shapes of a graph with talking about their types of distributions. We have left skewed, symmetric, and right skewed, including the different types of measuring central tendency, talking about arithmetic average, the median or the middle number that divides our data set into 2 equals halves, and the mode, the number that shows up the most. Yeah, if you found this helpful, consider liking and subscribing. But otherwise, we'll see you next time. Time to get on out of here.